My name is James Sitcombe. I come from East Yorkshire, used to be Portsmouth, but I moved recently. I work for this group of freelance consultant training people called Rove. We can come along in your business and we'll charge you lots of money for you to ignore our advice. So instead tonight I'm going to give you that advice for free. Woo! Like free stuff. So this is how we do quality stuff in PHP, right? We add usleep with the build number in to our code, and then when the business complains that the code is getting slow, we remove it, an instant profit. That's not how we do quality. So what is quality, right? It's kind of a bit of a vague word, perhaps. What does it mean? Maybe it means something like really precision engineered, maybe less so this particular brand of laptop these days, but traditionally perhaps, meticulously created with a lot of attention to detail, very finely crafted and so on. Or maybe it's something like a Land Rover. They're British cars, well known for their durability. They're built with quality components that are resistant to mud and rust and bombs possibly, and they're built to last a long time. Or maybe it's something like carpentry, where you spend a lot of hours putting in a lot of, handcrafted, a lot of love. You make a lot of mistakes, potentially. I certainly do with my carpentry. You put a lot of persistence into that. So I think we need more of this in software. Not just PHP applications, but all kinds of software, whether it's front end or back end. But I'm going to focus on PHP because that's what I do a lot of. So quite often I've had discussions with colleagues that end up in us agreeing that the best code is no code at all. Unfortunately, this is not very practical because you'll get fired very quickly. So maybe don't do that. So we need to make some trade-offs. We need to be practical about what we're trying to do, okay? And it's worth mentioning that we don't always need to make high-quality PHP application or web applications. For example, if you're prototyping stuff, making a short-lived brochure site that's going to only be chucked up for like 1 or 2 weeks. And it happens, right? Maybe we don't always need this high-quality, well-tested, well-built, following all the best practices application all the time. What I'm going to talk today is about products, about stuff that you will work on for several years of your life. Or maybe if you're a consultant or freelancer or contractor, you'll come along to a project and the project will probably outlive you perhaps, but you still need to put in your best effort to make this a good quality piece of software. And what I find quite amusing, or not amusing, what I find interesting rather is the correct word, is that open source software very much mirrors a long-term project or product. And they share a lot of similar traits, right? Open source software is a long-lived project itself, right? Most of them are. So what's quality in applications? This is not a specific thing. This is not just about writing neat code and stuff like that. This is about the whole process. This is about planning and thinking about what you're going to do. This is about developing it, documenting it, testing it, automating those tests, doing things like code review and then deployment and aftercare afterwards. So there's a whole process, and I'm going to have a look at some of that stuff today with you as quick as I can. It's a bit of an overview because I've only got an hour and I'm trying to fit like however many years of experience I have into a very short amount of time. So I'm not going to lie, this stuff does take time and therefore costs money, right? Time is money. But what I found over and over again is the investment up front in building a good quality piece of software will pay for itself. And it's key. This quote sums it up nicely. A freelancer at $25 an hour for 100 hours still costs more than a freelancer at $150 an hour that takes 10 hours to do the same task. And this rings true over and over again. Some of the contracts that Rover hired to do will be saving a project from going down in flames. And we will come along and say, you asked us, you wanted to hire us like a year ago, and now your project is failing. Why didn't you just hire us the first time? And you say, oh, we're too expensive. But now we can come along and fix it. And it'll just cost you a lot more money because you've wasted it. Never mind, get an expert in. I'm not saying hire Rove, but do. But getting someone who knows what they're doing is really kind of important, right? Whether that's someone in your team or whether you want to hire a consultant, do a bit of training or something, to make sure that you're knowledgeable as possible about what you're building. They can train you, they can mentor you, they can set you in the right direction, right? Even if you're a senior developer, it helps to have another sounding board to say, I've had these great ideas, what do you think, right? And if you're in a company of like 2 or 3 developers and you're the best developer there, you've got no one else to talk to tell you that your ideas are terrible, right? And we need that. We need to be told that our ideas are terrible. Or, hopefully, they're a good idea and that we can develop them, right? Maybe say that in a bit nicer way, that your ideas are terrible. Maybe it's not great people skills there, but this talk's not about people skills entirely. So yeah, these tips that I'm going to show you today are from my experience of working with high complexity applications, high complexity software, long-lived products, open source software. And I'm going to give you a disclaimer that hopefully not all of this is new to you. If it is, great, you're going to learn lots. If not, this is good advice, and hopefully you will agree that this is good advice, or at least some of it. It's very opinionated, but it's okay. In reality, there's no secret to building great quality software. It's about following processes and making sure that you know when to cut the corners and when not to, and so on. I'm sure we've heard that many times before. And maybe the not so experienced people will always think, well, what do they mean by that? But then as you get more experienced, you will realize what it means to know when to cut the right corners, because if you think, oh, okay, I'll cut this corner, and then a year down the line, you think, oh, I shouldn't have cut that corner, then you know not to do that again, or why it went wrong, so you can fix it next time and things like that. So experience helps a lot. But following processes is kind of important. This planning stuff, the developing, the testing and things like that, just do it, all right? All of this stuff, let's have a look at it. We'll start off with planning. This is an integral part of software, believe it or not. Often not done in enough detail at all. Sometimes completely overlooked. Oh, let's do this. Okay, great. Dive in, start writing some code. That's not how it should work. Hopefully we do at least some planning and have some kind of discussion, maybe some kind of vague spec docs that tell us what we should be doing. That's not always the case. Effective planning is rooted in good communication, being able to discuss with business stakeholders to say what we're trying to do, right? And that's not just spoken communication, but it's also all forms of communication, email, documentation, writing things down in a big document to say this is the big specs document, or breaking things down into user stories, if you like. However you want to do that, it's about effectively communicating and discussing those things. When you are discussing things, whether it's through verbal communication, which is going to happen a lot, hopefully, but when you're planning these things out, you need to be strict on using the business terminology. Don't talk about how you're going to detect a MIME type and store some XMLs in S3 and use a SAX parser to extract some data, because it means nothing. It means nothing to the business, right? Those business people that you're working for, more often than not will not know anything about tech. So their eyes will glaze over and they will start thinking about how to make money elsewhere in the business, right? It means nothing, because it doesn't describe the behavior of the application. Instead, we need to talk about things like how a user can upload their bank statement and reconcile the transactions against their accounting package. That's much better. It describes exactly what the application is supposed to be doing. And instead of saying things like user, we need to use other terminology like my accountant can upload their bank statement, the statement from NatWest or whatever, and reconcile the transactions and so on. And that allows the business stakeholders to be involved in that conversation, and that is really important because they know how the businesses work. And I've learned this is more and more important as I've become a freelancer and I've come into a company, and suddenly I need to know everything about what this company is doing, and I need to do it as quick as possible. So the only way to do that is to engage with these people, right? They're not like weird demons or anything like that. They're not going to bite our heads off. It's fine. You can talk to them, all right? And we have this flowing conversation. And so avoiding things like jargon as well, all right? So that goes to the other side as well. If they start saying, oh, you know, we're going to do something with our footsie and whatever, all right? I know it's a stock exchange, it's fine. But, you know, if they start using acronyms that you don't know what mean, then call them out and say, look, what does this mean, right? And that may be something specific to the business, or it may be actually a terminology that was rooted in, you know, some developers ages ago, maybe in a previous job that they had, and they say, oh, you know, we use the MIME types. And they're like, why are you saying MIME types? You don't know anything about MIME types, right? Because we've instilled in them that that's important. Another offender is like treating everything like an Excel spreadsheet, right? We want to avoid that. We want to try and figure out what the business processes are. If the business process is, oh, we stick this thing into a spreadsheet, we send the spreadsheet to someone else, and then you know, someone else handles that and turns it into a nice printed PDF or something, right? That's not really a business process. That's how they carry out the business processes. So we need to kind of understand why. This, for the astute among you who are versed in this thing called domain-driven design, which is all very popular these days, in PHP anyway, it's been popular in other languages for years. This is called ubiquitous language. I'm very keen not to enforce on you DDD concepts, but this is a good one to pay attention to. So if you do nothing else but this is what you should do. Use business language. So we need to explore and discover and find what reasons why changes are being made. We want to build a comprehensive picture of what's going on, right? Don't just accept that spec that says, oh, can you add this cool feature? Okay, great. It's not how it works, right? We need to question things. We need to explore a bit deeper. We want to understand the motives. Why are we doing this? You know, what business problem it's solving? What do you want to achieve and why and so on? We want to discover the intentions of the business. So then we can build a model of it. This is not a physical model, right? This is a shared mental model, all right? We're not playing Games Workshop games at the moment. We're doing software. So we need to discuss this and visualize it, even ephemerally, right? That's okay as well. We need to be able to distill that conversation down so we can refer back to it later, whether that's by doing processes like event storming. You don't have to do this, but drawing things on a whiteboard works beautifully, right? Whiteboards are great. Look, there's one here. You can write on them, rub them off, and have a conversation. You can all stand around it, right? How many times have we done that? So many times, right? Hopefully. If you haven't, try it, because that conversation flows so dynamically. And write down the important things, of course. All right, but you can use post-it notes. You don't have to follow event storming. This is Alberto Brandolini's technique for sticking post-its on a wall. You don't have to follow those exact procedures. Just use post-it notes however you want. At the end of the day, it's all about that communication and that conversation that you're having. And then we can document it, right? We can digitize it. And these graphs and stuff that you can build, you can put straight into the documentation. And hey, you've already started documenting your software, and we haven't even written a line of code yet. Woohoo! But businesses change. They keep changing. Damn, that's annoying. So we need to be able to plan for that. So we need to understand that businesses do change, sometimes drastically. All right? I've worked at companies, a company, the one before I joined Rove. For 2 or 3 years I worked there, and then suddenly the course of the business completely changed, and we worked with it. It was okay. It does happen, right? So your model needs to be able to change as well with it. So you need to keep your documentation up to date as well. So when things like that happen, when changes happen, have more discussions, right? And update those documentations. And that, as we know, outdated documentation is not useful at all. So development. This is the part we're good at, right? We need to care about our code, right? And I said it's not just about code quality and code style and things like that, but it is a facet of that. Style, layout, consistency, structure, and things like that, Right? Think about other professions. Plumbing, does a plumber leave sealant and mess everywhere and bits of pipe lying around after they finish their job? Hopefully not. Otherwise, maybe you've got a crappy plumber. Should tidy up after themselves. An electrician, right? Same thing. Do they just leave wires dangling around so you can walk around your house getting electrocuted? No. So why, as a programmer, do we feel it's okay to write rubbish-looking software that no one can understand? Because the next person that comes along and tries to read that code will be like, what is going on here? What was this person thinking? Were they drunk? It's quite possible they were, but hey. Yeah, we need to care about how things look. Luckily, most of this can be automated. We'll have a look at that. So there are only two hard things in computer science: cache and validation, and naming things, and off-by-one errors. This quote, the original one, attributed to Phil Carlton, and highlights something very important. And that is relevant to the conversation we were just having about planning, because naming things is really hard, right? It's about a balance of being descriptive and concise. For example, simple bean factory aware aspect instance factory tells you exactly what it is, doesn't tell you why. This is from Sprint framework in Java if you're not familiar with it. And it's a thing, and it's okay. But it's maybe not the best named thing, arguably. Or loader. That's the opposite, right? What is it loading? Why is it loading whatever it's loading? We don't know. It's not giving us any intent. So there's a balance. And I've used the word intent several times intentionally. We need to ask ourselves, what does this thing do? And why does it do it? If the answers aren't clear, then we need to go back to our domain model. And we need to go back to that planning stage and talk with our peers, the business stakeholders that know what they're talking about, and try and figure out the answers. If you can't, it's okay to give awkward names to awkward concepts. There was a talk from the DDD book author Eric Evans, which sums this up perfectly, and the talk was about imperfection in software design. Those who have adopted DDD feel very dogmatic about it, and they want to make everything perfect and modeled beautifully. But Eric, in this talk, points out that that's not the point, because business processes aren't perfect, right? There will always be flaws, and therefore there will be, or should be, flaws in your software. So if it's not quite, you haven't quite figured out what's going on yet, it's okay to give it a weird, awkward name that you look back and think, yeah, I'm still not sure, but then one day it might click and you think, this is where we're going wrong. You can go back to that, and it's like a marker to say, the waters are muddy here. Let's fix this later. It's like a to-do, right? Also helps to write to-do by it. Yeah. Solid. Who doesn't know solid? Okay, cool. Right, I don't have to go into that. Keep it simple. Just do it, right? As developers, we love, in general, I generalize a lot sometimes. That was like a real meta joke, and I didn't even mean to do it. Developers have an overwhelming desire to overcomplicate things, right? We're very, technically minded, and we overthink things and overcomplicate them. So let's try and avoid doing that, because you know what? If we make things more complex, it makes it harder to test, it makes it harder to document. We need to plan it in a lot more detail. And, maybe by overcomplicating, we've actually completely missed the point of what we're trying to do. So stop thinking about, how many Redis clusters you're going to have and whether you're going to have a RabbitMQ or a ZeroMQ, because it ultimately doesn't matter. What matters is that we're solving the business's problems. Who's heard of object calisthenics? Okay, cool. Only a couple. There is a talk, which I won't go into too much detail here because there's a whole talk about this. Talk by Rafael Domes, some weird Brazilian guy who moved to Amsterdam some time ago. He's not that weird. Don't tell him I said that. Damn, it's being filmed. Sorry, Rafael. Object calisthenics talk, and it's about trying to help reduce the complexity in the code itself, right? Not necessarily the domain model. In its rules, you don't necessarily always have to follow them, but a good practice, I suppose. One level of indentation per method, right? So instead of having this huge, sorry, this way for you guys, huge load of indentation, which, we've seen the Hadouken thing and all jokes like that, avoiding things like that. Things like avoiding the else keyword, that's an interesting one, right? And that's taking into practice things like return early and so on. And actually, things like that make code more readable, in theory. Wrapping primitive types and strings and so on, right? We'll have a look in a bit more detail at that in a bit. One object operator, which is basically obeying the law of Demeter, the principle of least knowledge, right? So this talk goes into detail about what these things are. If you have no idea what I'm talking about, it's fine. Just go and watch that talk. I'll dig the link out for you after, and you can have a look at it later. I recommend it highly. Avoiding early abstraction is another good tip. We're told constantly, don't repeat yourself. If you have to write the same code twice, then you abstract it away and things like that. But there is, I think, more nuance that we should apply here. There is a careful balance between early abstraction, which is when we've done the wrong abstraction. And the way to overcome this is by looking at your domain model and thinking, is this model clear about where abstraction should happen? And if not, don't create the abstraction, right? A good quote from a colleague of mine, code for your use case, not your reuse case. That is to say, just code for what you're trying to do and stop trying to think about everything that your code could possibly ever do, all right? Obviously, if there's the next task you're about to work on is something that you need to plug into it, then that makes sense, right? But you're about to write that code. But if it's just an idea of thinking, oh, that would be cool, maybe we could, have this abstraction so we could do this in the future, you'll never get around to it because you've not been asked to do that. That's not the use case of the code. Caring about your API, and I don't mean web services here, I mean your class's public API, the thing that defines in libraries whether there's backwards compatibility breaks and things like that, and how many times have we used a library and then suddenly this method that we were using has disappeared. If you don't know what that is, that's a backwards compatibility break. So the way to overcome this is by making everything private by default. Not protected, you say? No, not protected, because protected is still public API. You can extend your class and use that, right? So therefore it's public API. Properties can keep state, that's fine, make them private, but your public methods should have strict invariant types for the parameter type declarations and return type declarations. Another interesting quote about this subject. A public method is like a child. Once you've written it, you're going to maintain it for the rest of its life. And it's so true. And that's why we have Semver, right? And then you have the libraries that say they're following Semver, but they don't. And maybe this is why most of the Node.js ecosystem is still on 0. whatever, so we don't care about backwards compatibility. In your face, consumer. So yeah, strict type declarations. So we should be using strict types by default. For those of you who follow me on Twitter, I'm sorry, there was a recent debate which I tried very hard not to get into, and I succeeded. Recently, Zev was discussing about how strict type declarations were rushed and stuff like that. But the point is so many libraries have adopted just using strict types, and that's the right way to go. I strongly believe. You may disagree, but that's all right. We're allowed to have differing opinions, right? They matter for basic things like ID introspection, right? It helps you know what your methods expect and what they return and things like that at the very basic level. They're visible in reflection if you do weird things like that. Hopefully you don't. But it reduces that cognitive burden, one, on your mind to say, what does this function want? And what does it give back to me? But also, it allows you to do this thing called static analysis, right? Static analysis is this thing that you may or may not have heard of. It's basically looking at your code without running it and saying this code is good or bad. Or this code might break here, or it might break here. You know, this parameter should be this, but you're giving it this, and things like that, right? So I encourage using this because you'll pick up bugs a lot quicker. Something that we've had for a long time is object type declarations in PHP. At least for parameter types, we can now return things, have return type declarations as well. But using things like value objects, if you've never used a value object, it's basically encapsulating a value, as the name may suggest, into an object. And the object has its own validation here. So this is kind of very, it's a typical example. Email address is another one. You know, you're validating against a regex just to make sure it looks like a valid one. But note that there's no way of changing the value here, ever. There is ways, but they're really naughty and don't do them. The class is final, so you can't extend it. The constructor, we can make it private and do a from string perhaps, so you can have multiple named constructors if you like, but it roughly looks like this, right? So you can cast it back to a string and you can give it a string, and that's all you can do. But every time you want a new value, you create a new object to go with it. And what this means is there's no way of ever creating an invalid postal code. So value objects used in this way give consistency in your code and allow you to set your expectations very clearly. For example, this assign postal code method here. If we give it a postal code and try and instantiate a postal code with the string 12345, that's not valid for the UK, that will throw an exception. If we try and assign a postal code with PO11AA, then it will work because that's a valid postal code. And if we try and pass it a number, 12345, if we've got strict types on, that will throw an exception. Otherwise, it will actually just cast it into a string, which is just messy. But the assign postal code method, it can now make assumptions like that postal code is a valid postal code. It will only ever receive something that's valid. So, we could put that into a database and it will always be valid. And when we take it back out of the database, we stick it back into that value object and pass it around, and anything that expects a postal code object will always get a valid one. If it comes back out of the database and it's suddenly invalid, maybe you changed your validation, or maybe someone tampered with the data. So testing. Ah, yes, testing. We all know about testing, right? We all know we should probably be testing better. Who is happy with the amount of tests that they're doing? Really? I asked the question worded very specifically because as PHP developers, we write code, we hit refresh or make the post from an API call, whatever we're doing, right? And that's testing, right? We don't just write the code and throw it over the fence. We test it first. It's just we do it by hand all the time. So who is happy with the amount of tests they've written for their code? Okay. Who doesn't write any tests? All right. Testing is not a separate line item. Often I will get told, my boss doesn't give me enough time to do testing, or my client didn't want to pay for testing. And I'm like, what, you want to give them something that's not tested? My mind doesn't comprehend that. I've conditioned myself to think that way, of course. If you're new to testing, and you've never done testing before, there is an initial learning curve, right? So maybe your productivity might go down a bit. And it will increase the quality of your apps immeasurably. It will catch bugs, it will catch regressions, it will catch things that you never thought it would catch. I've written tests for code that I've written, and oh, that's really buggy. I'm so glad I wrote a test for that, because otherwise that could be in production, right? And the sneaky way to overcome that problem of, oh, my boss doesn't want me to write tests because it takes time. And the best way of doing it is kind of, if you're an in-house product and you're a full-time employee, things like that, is just to start doing it, all right? In my opinion, and others may disagree, but in my opinion, you shouldn't need permission to write good quality software. And testing is a key part of that. So if you're not delivering software that has been tested and comes with a test suite, then you're not delivering a good product. It should be an assumption, right? Would you buy a car? And when you buy a car, you assume it's been tested. At least they've done a couple of crash tests, maybe not on your particular model that you've bought, on the particular one that you bought. But that line has been tested, and they may pick a car off the production line and crash it just to make sure that all the safety features work or something. I don't know, I don't make cars, I don't know how they do this thing, but I assume that they test them, right? That my airbag is going to go off if I drive into the back of something. It's never happened, touch wood, so far, but I hope it does, all right? You're already testing. As I mentioned, you're manually testing stuff every time. You write some code, you refresh the page, you write some more code, you refresh the page. Oh, the error is gone. Great. All right? So instead, we just need to automate that. We need to write a test to say, these are the things that this function is supposed to do, and do it, and then it does it for you. So then you can get in the habit of, whether you do TDD or not, which is where you write the test first, I don't care. As long as when you come to push that change to your repository, it's got tests with it that verify that what you've done works and will carry on working. Does your boss or you or your team still need convincing? You just tell them. It's proven over and over again. We will get less bugs. We will find less regressions. It will force us to design code better. And hey, if you have that big legacy mess, which most of us have worked on this kind of thing before, or maybe we're forming a legacy mess now for the next developer, I don't know. Testing on this kind of software is still possible. It's a bit more of a challenge, but I'll suggest a way in a bit when it becomes more relevant about how we might be able to go about that. But unit testing in general, right? How do we go about that? It's quite simple. On an existing or legacy software application, you make a new rule. A very strict, hard and fast rule that no code gets merged into the repository without tests. All right? New features, tests. Fix bugs, tests. They should pass, obviously. And over time, your code coverage will increase, right? There is no point in trying to sit down for like a week, 2 weeks, or a month, or whatever, and say, let's all write tests for all this existing code we've got, because it is probably the most mind-numbing thing I can think of doing. Oh, God. Yeah, don't do that. Who's ever done that? I have, and it's really dull. It was very demotivating, and it was when I was just trying to learn testing as well. I was like, that's the wrong way to do it. So don't do that. If you're writing a new application, a greenfield project, hey, you know what? It's the same thing. You just make this rule, no tests, except you're starting at the very beginning, so you're going to get 100% code coverage to boot. So testing, as I mentioned earlier, allows you to spot and reduce complexity. A hard test to write, a hard unit test to write, is the result of complex code. There's no two ways about that, really. So you need to be able to reduce the scope of methods, avoiding big procedural methods that do tons of things. Break it down into smaller, meaningful operations. Atomic operations, right? And use the naming from your domain model that you talked about earlier. What is this thing doing? Oh, it's sending an invoice. Well, what steps do we do when we send an invoice? Well, we create, we draw up an invoice, we add some line items to it and stuff, and break that down into smaller things, right? That mean something along with your domain model. So like this single method, which has lots of complicated code in it, lots of logic and loops and branches, code branches here. We don't want to do this, right? We want to break it down, all right? Using things like object calisthenics, which is that talk from Raphael Domes I mentioned earlier. I'll give you the link later if you need it. First of all, pick a better name than just process, because it means absolutely nothing. Use words that describe what the business is trying to do, like throw stuff into the fire and combining string yarn with fire, things like that, and posting flowers to Spain, right? It's a weird business. More complexity is more tests, right? So let's think about test coverage. How do we get 100% test coverage? Anyone? Take a guess. Come on. How do we get 100% test coverage? It's possible, but it's the wrong question. The goal is not to aim for 100% test coverage. The goal is to aim for 100% of your domain logic to be covered with tests. That's important. That's the important part, right? So that's the goal we should start off with. It doesn't matter whether we're testing whether MySQL connects or MariaDB or Redis stores things right? That's not a job for unit tests. Unit tests, let's start off with focusing on the business stuff. Sending flowers to Spain and throwing stuff in the fire. Hopefully not the flowers, otherwise we wasted the money. And another problem with code coverage is that it's very difficult to measure real code coverage. Let's have a look at some code. In this function foo, we are doing two checks. If A is A, we'll echo A. If B is B, if B is true, we'll echo B. Fairly straightforward method, right? Hopefully we can follow what's going on here. And tell me yes or no, can we generate 100% test coverage, code coverage using these two calls? Why does everyone always shake their head? It will go green. But you're right to shake your head, right? Because this isn't fully covered. There's this branch where A is true and B is false, signified by this nice purple line. Where B is true and A is false. So that's the two calls we've done here. But there's actually two more, where they're both false and when they're both true. Now, Xdebug supports this way of generating code coverage, but the PHP unit code coverage generating display thingy tool, whatever it's called, it can't display it, because how do we display this in a way that makes sense to us? It's really, really difficult. So we haven't come up with a useful solution for this yet. It's possible, it's just too unwieldy for us to be able to figure this out properly. So actually we need 4 tests, because there are 4 code branch paths that we can follow in that method. Test coverage from leaking. Yeah, we don't want to leak coverage everywhere. What do I mean by this? Using the @covers annotation on your test case will allow you to restrict coverage to that one class that you're testing. That will allow you to test the private API of that class. And bear in mind, if there's a private method that you can't cover with the public API and writing tests for that, then there's some weird stuff going on in your code. Right? You should always be able to call private methods and cover the logic in those by calling public API of a class. So aiming for 100% test coverage is usually impractical unless you're writing from very scratch. It's also not that worthwhile goal, right? We want to test the domain logic really is what's important. The point of a test is to make sure that everything's working. So if your test is not performing the correct assertions, then your tests are not testing. So how do we stop this? So let's have a look at this example. This is not a useful test. Not all that useful. I mean, the code is executed, so we generate code coverage. Hopefully the problem is kind of obvious here. We're not actually doing any assertions here. So let's put some assertions in, right? We maybe want to say that the event listed on the receipt is the same as the event we created, that we've got one customer on it and the customer is the one we expect, and things like that, right? That's a fairly trivial example. But we can do better than that. We can test that our tests are testing. We need something called a mutation testing tool. All right? There used to be two. There used to be a tool called Humbug and Infection. Now there's just Infection because Humbug got a bit difficult to maintain. Infection PHP is a tool you can just run, and it will run your unit tests, but it will then change bits of the code, and then it will run the tests again. And if the tests fail, that's good, because it changed the code, it broke your code, and the test failed. If the test still passes, and you broke the code, then that's not good. All right? That means that your test was not testing what it's supposed to be testing. Let's have a look at an example, because that might be a bit difficult to comprehend. So we've got add, right? We know what add does. It adds two numbers together. And we've got a test that says, well, the result is the adding 2 and 3, right? But I've left the assertion commented out so that it's not testing anything. So if we run this through Infection, it will create maybe a mutation that changes the plus to a minus. Haha, it's now subtracting. But if we run the test, Infection will now run the test automatically, and if it hasn't broken, it will say, your test is rubbish. Fix it. If we uncomment the assertion, obviously the test will now fail because it doesn't calculate to the correct value. All right? And the nice thing is, Infection PHP is pretty much, more or less, something you just chuck into your CI and it works. Takes a little longer because it obviously has to run the tests over and over again, multiple times. It's a bit more clever than Humbug used to be, which is nice, because Humbug used to run the whole test suite, change something, run the whole test suite, change something. And obviously that's a bit rubbish. Took some time. So what about other tests? I harped on about unit testing for a while. And there are other kinds of tests, right? We've got integration tests, right? That's where we check that stuff happens in the database properly and stuff like that. There is still value in there, but you probably don't need as many of these tests, right? You don't need to use your real database and things like that to check that often. Maybe if you've got some weird, massive SQL query, or you want to check that the data you put into Redis comes out looking the same and things like that. They're useful integration tests because you're integrating with your infrastructure. That's what the point of them are. Integration tests aren't concerned with business logic, though, right? Only concerned with integration, funnily enough. And behavioral test is another important one, right? This is where we want to focus on as well. So unit tests and behavioral tests are the most valuable tests, I believe. And this is where we can describe the business logic, which is also how we can document the business logic. And that, I think, is the most important part of behavioral testing. Not that we're actually testing and making sure things work, but that we're documenting how things are supposed to work. This is not a good test. Don't write tests like this. If you've never seen Gherkin before, don't write anything like this, okay? If you have, and you recognize this kind of layout, stop it. This is basically a very fragile UI test. And it's not very useful. And it's not readable to someone who knows nothing about what a .bref ipt -fld or a booking ref.print thing is. It means nothing useful, right? There's no meaning, there's no intent, there's no figuring out what it does unless you're a developer. And that's not the point of this. We're trying to document how the business works, not how the application works, all right? So let's change it. This is a good test, or at least it's better. Let's look at what's good. Firstly, I'm using the free text area. I've written a label called policies, right? You can write anything you want. You can put some ASCII art of a cat if you like. Probably more beneficial if you write something useful though. I'm documenting policies or business rules, if you want to call them that. Right? Boarding passes are only available when you've checked in for the flight, right? If the customer can't print a boarding pass, maybe some airports, you have to check in manually. You can't check in advance and things like that. All right? So another big change is that this scenario that we've written, it contains no references to UI elements, right? No CSS, no, I click on this button and things like that. There's nothing like that. It's just describing what the customer does, the passenger of this flight, right? We're describing the behavior of what happens, when they've checked in for the flight. I should be able to print my boarding pass, blah, 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 right? Additionally, a bit more of a subtle one is that we've got a given, when, and then, right? And that's what should happen. don't have lots of whens and thens. If we go back, we can see we've got a given when, then, and then a when and a then. Right? That's basically, we're testing more than one behavior here, which is not what we're trying to do. Right? There should be a predicate, an action, and an outcome, and that's it, in that order. And finally, and possibly most importantly, we're using a real-world example here, right? Maybe this passenger is flying from Heathrow to Miami on the 24th of May. They've got some booking reference and they've checked in. They should be able to print their boarding pass. But maybe for some routes, maybe if we're coming back from Miami, we have to check in manually at the desk and print the boarding pass. So maybe that particular route, with a separate example, a separate scenario, it should say, we can't print the boarding pass, and so on. But the point of using an example is that we can discuss that, right? Because the business stakeholders can understand this, right? It's plain English. We know what's going on. They know what's going on. So we can have a discussion around it. Oh, what if they fly from, Prague or something like that? Oh yeah, we don't print boarding passes in Prague, so, okay, let's write a test. Or maybe we can reword the scenario to say, I've booked a flight that flies from Prague. When we fly back from Prague, we can't print boarding passes, and so on, right? So why is this important? I've kind of said this already. I gave you a spoiler. Because we're testing behavior, and we're documenting those business rules as we go along, because they will stay there in the source code and tell you what's going on, tell you what the application does. So if you get someone coming along new to your code base and that says, so what's going on here? It's my first day, I have no idea. Get them to read the tests, these behavioral tests. If they're well written, they'll be able to pick up very quickly how your business works because you've documented it, right? Then, once we've written them, we can go ahead and automate them. We can use this magical funky tool called bhat. Right? So far, in writing all these tests, we didn't even run bhat. We're just writing things down, that's all. But bhat makes it easy to test them, right? And there's two ways of doing this, right? We can write it at the application level. We can write a UI test. We can navigate things in a browser. But hey, what happens when we want to expose an API? Oh, okay, well, we can't click this CSS element or JavaScript button because there's no HTML anymore. Okay, so we need to write a different set of tests against the API. And then what about when we want to write an Android and iOS apps? Well, there's a whole two more test suites we've got to add now. What I recommend is when you're first starting off with stuff like this, actually test at the domain or business logic layer. Forget about the browser. Forget about your handheld devices and things. What you want to start with is testing your domain logic and making sure that works to start off with. No UI interactions means it's immensely fast, right? I've written test suites before that are like 3 hours to run because they're clicking through things all the time. And it does it very fast. If you watch it, if you visualize it, it goes very quickly. But it still takes ages, right? So this is an example of two of them, right? The bottom one, using the domain layer, we're just calling methods on our domain objects directly. If we want to display a booking reference, we can retrieve the booking. All right, we want to be able to retrieve the booking. How we display that is not important. It's just we want, maybe we want to check that there's certain elements returned in that booking reference and so on, so we can see what's in there and display it. The top one is the UI test. You may have seen this kind of stuff before. We're clicking elements, we're finding a field, we're setting the value of it, we're clicking a button and things like that. UI tests are okay though, right? And going back to how do we test a legacy mess thing, this is actually the first thing I would do, right? If you have a project, in many cases, this is the first thing I would do. If you have a project that has no unit tests, nothing, and it's a legacy mess, and you know it's completely untestable, write a UI test, just one, to make sure that the happy path that the customer should go through works, right? So, we can book the flight and we can print the boarding pass and things like that, right? And we've got one test there. And that's great, because we're testing that the business logic works. The code under that UI test might be horrendous, but that's okay, because what we can do now is start refactoring stuff underneath that test and re-implementing things and changing things around. And when we do that, of course, we write unit tests along with it. And they'll start passing. And as long as that UI test that you've written still passes, that's good, right? We haven't broken the key functionality. Yeah? And then you can write a couple more UI tests, maybe one for like a failure case and things like that. But the happy paths are the important ones. And once we've got those tests going, as I said, we can refactor underneath and add unit tests and integration tests as we go along, like it was a new project. And that's how we would go about refactoring legacy stuff. Automation is key to creating this smooth workflow. What do? Well, continuous integration is the answer, really. Every change must be tested in continuous integration. You run your unit tests, your BHAD tests, your coding standards tests, you run your migrations, things like that. Why? Well, because developers hate running tests manually. It takes time, and we forget. And it costs money, right? Tests cost money to run. When you're sitting there and your BHAT test suite takes 3 hours to run, you are wasting money. So it's a false economy to be running all this stuff manually. You need to pay a machine. Like Travis costs $250 a month or something like that for a couple of executors. It's so simple to set up. There's no excuse really. If you've got tests. If you haven't got tests, well, that's a different story. Maybe you weren't listening for the last 20, 30 minutes. Jenkins, yes, there's Jenkins, right? We can set up Jenkins if we want. It's open source software. I love open source software, but it's not really free because there's a maintenance burden. Anything that you host yourself, there's always a maintenance burden, right? Jenkins likes to update quite frequently, so you've got to keep up to date. What about when it breaks? Who do you contact, right? At least with Travis, you can say, oh, it's broken, they're working on it, let's play some ping pong or something, if you like ping pong. I would say that in like 99% of use cases, stuff like Travis and Circle CI will fulfill all your dreams and needs. If you've got really complex business requirements or some weird bank thing says, oh, we're not allowed to let the source code out of the building, yeah, like that happens, then maybe consider Jenkins. But honestly, this stuff is fine. So what do we automate? It's very simple. Everything, right? Unit tests, behavioral tests, acceptance tests, end-to-end tests, coding style tests, database migrations. I bet we don't have enough of those in our CI runs. Front-end builds, your JavaScript tests, things like that. Make sure that Gulp or Grunt or Webpack or Yarn doing what they're supposed to be doing and generating what you expect to see. I've even seen tests where it takes screenshots and compares them with the previous version, right? Any kind of thing, plug it into your CI environment, because the goal is this, the red or green thing in GitHub or GitLab or Bitbuckets. That's it. You just want that green thing. If it's red, don't merge it. If it's green, you go to the next stage, which is code reviews. Code reviews are important for education, communication, gatekeeping, and generally keeping the quality of your software up. So if anything, I think this is the most important thing of this talk. And I've left it to the last 5 minutes to rush through it. The reviewer, the code reviewer, must absolutely have authority and supreme power to say, don't merge that, it's terrible. Which is a really hard thing to do in some teams, right? Because they will say, well, what about when production's down and we have to quickly ship a fix? Well, if you've written a test with it, it should be fine, right? It can be a hard ask. A code reviewer must also be quite experienced. Right? And I'm not saying that inexperienced or junior developers should not be reviewing code. They absolutely should be, right? But the gatekeeper, if you like, or the gatekeepers, right, should be able to review this code, right? Because it's very important. They've got the experience, they've got the years, and you can only build this up with finding out the hard way. There's no two ways about it, unfortunately. So what do we look for? Code style, but most of that can be automated, right? PHP code sniffer, PHP CS fixer, things like that. So you shouldn't need to do it, but just keep an eye out for some weird things where someone started writing code backwards and weird things, right? Yeah, let's not do that. Also avoid refactoring style in features. So like where you're adding a new feature, don't suddenly add a new PHP CS rule and change all of the files in the project, because the reviewer will probably stab you in the eye. So make them small as well, right? Small atomic changes, that's what it's all about. Don't deliver one user story every time. Sometimes you might need to make several pull requests for a user story, because actually the user story might just say, as a user, I would like to click this button and the world explodes. There's a lot of parts to making the world explode. I mean, I'm not speaking from experience, but I imagine there's lots of parts here, right? So you're going to want to make lots of pull requests, small as possible. It's really hard to do this, right? I still make some huge pull requests, and then I get slapped around the face and say, you make a big pull request. And then I'm like, I'm going to put pineapple on your pizza. Try to keep your changes focused and to the point. Composer versions, right? Make sure you've got recent dependencies. Make sure you're using Rove security advisories. Don't worry, it's not something you have to buy or anything like that. You just stick it in your Composer JSON, Rove/security-advisories, and it will automatically conflict with known to be insecure versions of packages on Composer. It uses the data from Friends of PHP security advisories, and it's not fully comprehensive, but it helps, all right? Look for structure and good practices. This is kind of where experience starts coming in a lot more, right? Anyone could look at code and say, oh, that looks ugly. But it's a lot more difficult to say, well, does this service class fully implement all the interfaces so it can be final? Does it have an interface? Don't just create a final class without interface where it needs it, right? Value objects don't count, right? They're different. Are we encouraging the best practices or conventions that we use in the team? And challenge those conventions as well. Don't just accept them as these are the rules, we have to follow them forever, because if you don't keep changing your rules and keeping up to date, then you'll go stale quite quickly. Assertions for parameter types. Can you use value objects and so on? Are your return types, does it return like a true, a false, or a string? Yeah, don't do that. If you really must do that, encapsulate it in a value object. So you make those types well documented. Tests, got unit tests. Have they got feature files and so on? I think we've done that one. Documentation, I actually encourage you to commit your documentation along with the repository in just a docs folder if you like. Stick a load of markdown in there. Tell people what this thing does, why it does it, what business problem it's solving, and why you've used some weird component. Document things for your fellow developers, because they and you, when you come back to it later, will thank whoever wrote that documentation. So when you're reviewing code, just kind of think, do we need to make a quick markdown document to say what's going on here? Security as well. I mean, there's whole talks about this. You know, SQL injection, filtering, escaping, and CSRF and things like that, all right? I won't go too much into that, but look out for security stuff. If you don't know what you're looking for, look for the OWASP top 10. That's a great place to start, and then you'll go down a big rabbit hole. Also, are you getting the insight? Are you understanding what the change is? Maybe that is not conveyed properly in the code, or maybe it's overcomplicated and things like that. Takes practice. As I said, you know, the more you do this, the more experience you'll get. And the more experience in general, you'll be able to say, well, like 3 years ago, we did this same kind of thing and it blew up Las Vegas or something like that, right? So let's not do that. So you need that experience to spot problems developing ahead of time. But honestly, the real skill is being able to communicate your experience nicely. You can be opinionated as long as you can communicate effectively. And that can be difficult. Because you need to be able to solve disagreements without hitting each other over the head with baseball bats. Because you'll end up in prison. Some of this is very mechanical, black and white stuff. This is right, this is wrong, blah, 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 blah. Some of it's opinionated. It's best practices, right? I've told you some best practices which you'll probably disagree with, and that's okay, but your code's wrong and mine's right. Finally, in -1 minute, so I'm going to do this very quickly. Deployments. Automate them, it's very straightforward. Honestly, if we're not automating that, and that, what I mean by that is one click or typing a command to deploy your infrastructure, right? We shouldn't make it complicated. We shouldn't be having this document that says, to deploy, you have to do this, and then go over to this website and do this, and then you have to clear the cache and type this command and things like that. Because something, one day, if it hasn't already, will go wrong, right? So if we make a computer do that, and we tell it exactly what to do every time, it will do the same thing every time, and as long as you've written it right the first time, it won't make any mistakes. To implement this kind of thing, what do? It's very simple. You take those steps that you do manually to deploy, whether that's uploading, running Composer and then uploading it to an FTP site. Just use a tool that does that, right? There's tools like Deploy HQ, which will do that for you. Right? Even if you're using FTP, and don't laugh because some people still use FTP, right? It's a viable way it's a way to deploy things. The goal is essentially to always be deployable. So whenever you've merged the code, you should be able to deploy that straight away, in theory. Facebook's mantra, move fast and break things, which is, of course, dumb. So they changed it in 2014, whether you like Facebook or not. I wrote this talk before all the Facebook stuff, so whatever. They still have good technology, right? Whether it's ethical or not is a whole other topic. Yeah, but they changed it because they kept breaking stuff. And you know what? That costs money. Breaking things costs money. Sometimes millions of dollars, sometimes hundreds of pounds an hour, whatever, right? I changed currency there. That was weird. But my point is, if you are confident in your pipeline, so your tests, you have more tests, you put more and more tests in, and you write better quality code all the time, you can do things like continuous deployment, where as soon as you merge to master, it will deploy everywhere, right? So you don't even have to click or type a single command. Sounds pretty scary. And if you don't do this, you might be thinking, well, that's going to lead to deploying at 5 p.m. on a Friday or bank holiday Thursday. Maybe you deployed just before you came out to the user group meetup tonight. If you did, congratulations. Hopefully it's not broken now. But it is possible, and I've done this. You just have to have a lot of confidence in what you're doing. You've got to have the confidence that it's going to work when you deploy it. And you do that by increasing the quality, better planning and exploration to start off with. It starts way back there. Developing things better, testing more, better testing, because there's always things you can do better. And making sure it's automated and you have that red and green feedback and you have a good code review process. That will always lead to better quality software, which leads to higher confidence. Higher confidence, you're not going to break things when you deploy, that you are going to deliver stable software. And when you're doing that, you get a much higher frequency of feature throughput. Oh, we just deployed 5 changes today. Great. Business stakeholders happy. You carry on getting paid. And you get happy customers, whether that's your boss or your client if you're freelance. And ultimately, you will get satisfaction in delivering a great service, a great product, whatever. You will learn more. And as you start looking into the things I've very briefly covered today, because there's a lot more detail to all of what I've said today, right? And as you look into some of these aspects, and I hope I've inspired you to look into some of these aspects, you will become a better developer. And that's what we want. Woo-hoo. Thank you very much, folks. Cheers.